Hello. This is Kenya Suraj. Hello, this is Kenya Suraj. I want to take you through this course, Mathematics Made Simple for All. And I'm going to be the instructor for this course. I'll say something about me. Hope everyone is okay. And I want to thank you very much for joining me in this course, Mathematics Made Simple for All. As I told you, my name is Kenya Suraj. I'm a former principal of Rhodes Technical College, Kimberley, South Africa. I was also head of department mathematics in local high school, Sam Memorial College. I have taught mathematics for more than 20 years in colleges and secondary schools. My students getting best grades, and I always want to get the best from my students. Utilize all their potential because I know they can do it, but they just need really somebody to push it on. I've taught in countries like South Africa. I was a principal at Rhodes Technical College. I've taught in Cameroon, Uganda, and now I do also some online teaching. I'm a tutor on Superproof. Preply. I've also written many books, about 40 and so on. Then KDP Amazon, Cover Writing Life, Ingram Spark, Lulu Press, Draft Digital, Publish Drive, Google Play Books, and some other stores that I'm just using on the website. I'm also a digital marketing manager with Dashbooks. What do we expect in our study here? Our learning outcomes by the end of all these discussions, I anticipate that we shall have gained thorough understanding of the concept of numbers, how we apply numbers to solve common problems, reinforce skills in following topics, counting numbers, line, place values, mental math, number properties, integers. Also, it helps us in finding lowest common multiples to help operate fractions. It helps us in our life decision making, especially based on numerical information. Portions of all numbers as fractions and decimals, calculating percentages and the ratios. This course is also very important for those who are doing their tests in the TIS tests, AI TIS tests, and also those who are pursuing some diplomas in education. The topics mainly that we shall look at in our first course numerals, I can say, or the number types, the factors, multiples, integers, divisibility tests, number bases, fractions, decimals, percentages, ratios. Our first discussion is on numbers. That's our first topic. What is a number? Basically, a number is a symbol we use for counting any digit or value. And you have seen what we call the numerals, the Roman numerals. You are seeing I, or Roman 1, 2 I's, Roman 2, 3 I's, Roman 3, Roman 4, Roman 5, Roman 6, Roman 7, Roman 8, 9, 10, 11, that is XI, X for 10, XL for 40, L for 50, C for 100, M 1,000. So when you put I in front, it means 6. That means you're adding 1 to a V, which makes it 6. And when you put I behind, that means you're subtracting I from V, which makes it a 4. That's why you're saying I4 and then VI. I mean IV for 4 and VI for 6. The Hindu-Arabic numerals are the usual digits we deal with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as I've written them here. And they're standing in for the Roman numerals are put, and then it's here. So that is basically what we call the numerals. There are other numerals which I don't want to bring, like Arabic numerals and so on. So the types of numbers. We have many types of numbers. To mention, we have even numbers, odd numbers, counting numbers, natural numbers, consecutive numbers, whole numbers, square numbers, triangular numbers, prime numbers, composite numbers. We have rectangular numbers, and also we have what we call the cubic numbers. So what are the even numbers? Even numbers are numbers which can be divided by 2 and you get no remainder. Numbers like 0, 2, 4, 6, 8, 10. 0 divided by 2 is 0, 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3. That means if you get any even number, let me say the first even number, add on 2 to help you to get the next even number. Add on 2, get another one. Say 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, and so on and so forth. So you can get them by adding 2 to the first even number, and it will give you the next even number. Then odd numbers will do the opposite of the even numbers. Odd numbers are numbers that when you divide by 2, you get a remainder of 1. Those even numbers start with 1, 3, 5, 7, 9, 11, 13, 15. So when you divide 3 by 2, you get 1 remainder 1. 5 divided by 2 is 2 remainder 1. So that means you always get a remainder of 1. So you can also add 2 to the first odd number to get the next. So whenever you add the 2, you can get the next odd number. Then we have what we call counting numbers, natural numbers, and whole numbers. A counting number, you know these are our numbers you've been doing with our nursery or the pre-primary. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The list is endless. Then the natural numbers are all the counting numbers when you exclude 0. That means you start counting from 1, 2, 3, 4, 5, 6, and the list should be endless. All numbers are all the counting numbers. In other words, if you have n now which is not a fraction, that means it will be a whole number. Then we have what we call the square numbers. Square numbers are numbers that when you multiply a number itself to give the square number. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. In other words, 1 squared is the same as 1 times 1, 2 squared, 2 times 2, 3 squared, 2 times 3, and so on and so forth. So you're raising a power of 2 on a number to get what we call a square number. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. So the list is also endless by squaring the natural numbers, and you get the square numbers. You can also get the square numbers if you add the odd numbers. Say 1 plus 3 is 4, 1 plus 3 plus 5 is 9, 1 plus 3 plus 5 plus 7 is 16, and so on and so forth. Then we can move on to what we call the from the square numbers, we can also talk about the triangular numbers. Triangular numbers are also numbers that can form a triangular shape. As you also see that even square numbers can form a square shape. That means you find the length and the width always equal, the same. 2 times 2. The length is 2, then the width is 2. Now the triangular numbers form a triangular pattern or a triangular shape. Like you see here, I've used these crosses to stand in for triangles. So the first triangular number is 1. When you say 1, put 2, you get 1 plus 2, you get 3. 1 plus 2 plus 3, you get 6. So which means you can get the add natural numbers, then you're going to get the triangular number. 1, 1 plus 2, 3. 1 plus 2 plus 3, 6. 1 plus 2 plus 3 plus 4, 10, and so on. So the list is 1, 3, 6, 10, 15, 21, 28, 36, and the list continues. So those are called the triangular numbers. Then we have what we call the prime numbers. Prime numbers are the numbers that have only two divisors, that is 1 and itself. So the first prime number, if I talk about divisors, they're also called factors. You can also get them if you multiply that number 1 by that number. So that means it's also 1 and another and that number. So 1 times 2 is 2. 1 times 3 is 3. So they have only two factors. There are only two numbers you can multiply together that number. And the first prime number is 2, the next is 3, 5, 7, 11. You can see we are not including 4, cannot include 6 because they have more than two factors. And when they have more than two factors, we call them composite numbers. So a composite number is the opposite of a prime number. These are numbers with more than two divisors. So 4 is an example. It's the first composite number because it has factors for 4 are 1, 2, 4. That means 1 times 4, 2 times 2. Or 4 divided by 1 is 4, 4 divided by 2 is 2, 4 divided by 4 is 1. You can see that. So you can either call them divisors or the two numbers you multiply together, that particular number are the factors of a number. Consecutive numbers are these numbers that follow each other. Like when you say 1, 2, 3, 4, 5, those are consecutive numbers. They follow each other. 19, 20, 21, 22, 23, 24, those are composite numbers because they follow each other. So basically, you can also bring in what we call the cubic. You can bring in what we call the cubic numbers. We are bringing in what we call rectangular numbers before we go to the cubic numbers. Rectangular numbers, these are numbers that can form a rectangular pattern or a rectangular shape. That means you have the rectangle, any four-sided figure with the length the same as the width, or the opposite sides are equal. The opposite sides are equal. I cannot say the opposite sides. That means width, length, are equal. When you have a special rectangle is a square because it has the length and the width all equal. But these ones are only opposite sides equal. And you can get any natural number as a rectangular number because it can form a length and a width. So that is it for rectangular numbers. And you can form a rectangle out of them. If you form the length is 1 and width is 1, that's a rectangular number. Though it's also forming a square. The length is 2, width is 3, like that. Okay. Then the cubic numbers, before you go to the quiz, we have what we call the cubic numbers. Cubic numbers, these are numbers got by multiplying a digit by itself 3 times. Like 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And these include 1, 8, 27, 64, 125, 216, 343, 512, and so on and so forth. So those are cubic numbers because you can say 1 times 1 times 1 is 1 cubed. 2 times 2 times 2, 2 cubed. Like the way you saw the square numbers, you have 1 square, 2 square. These ones are 1 cubed, 2 cubed, 3 cubed. So you're multiplying the number itself 3 times. You get what we call the cubic numbers. So we shall go for our quiz, and then I'll give you a chance to try the quiz, and then we shall have a small break as we shall try to resume. So in our quiz, we are having those questions. Give a difference between composite numbers and prime numbers. List 2 examples of each. Then number 2, at the class assembly, learners form a pattern of 4 rows and 3 columns. In other words, you have to talk about the rows and the length, and columns as the width and C. So how can you form, determine the number of learners at a class assembly? From your answer above, how many possible rectangular patterns can be got? What is the difference between a square number and a cubic number? List two examples of each. Write the fourth and fifth even and odd number. List the first 5 triangular numbers. So that's our quiz, and you can try to answer them. If you are struggling, we can give you a solution hereafter and look at how you could have answered it. So composite numbers have more than 2 factors, where prime numbers have 2 factors only. Example of composite numbers are 89. Examples of prime numbers are 2 and 3. Then when you talk about the learners, 4 times 3 gives you 12. That means, as if saying 2 rows, 3 columns, 4 length, and then 3 column, which I mean 3 width, which is 4 times 3, which is 12. It's like a rectangle 4 by 3. And then the number of rectangular patterns you can get depends how many factors make up 12. And the factors are 6, so there will be 6 different patterns. In other words, if you say 1 times 12, 2 times 12, 2 times 6, 6 times 2, like that, you can form patterns of that kind. 3 times 4, 4 times 3, and so on and so forth. Then the square numbers are got when multiplying a number by itself, yet cubic numbers, and numbers got when multiplying a number by itself thrice. Examples of square numbers are 1, 4, 9. Examples of cubic numbers are 1, 8, 2, 7. The fourth even number is 6, fifth even number is 8. Fourth odd number is 7, and fifth odd number is 9. So you can get them by listing, and then you see which one is the fifth and which is the sixth. The first 5 triangular numbers are 1, 3, 6, 10, 12. That's how you can get them. Okay, so as we go in for our small break, we have our topic 2, which is factors. What are factors? A factor is a divisor of a number. One number is multiplied to get that number. So when you talk about a divisor, it means when you divide by that value, you want to get a remainder, so it becomes a divisor of that number. And those are factors. Mathematics. So we can denote factors. Say if you say fx or f subscript x, then that can be factors of x. Then f subscript 3, factors of 3. F subscript 4. When I mean subscript, that one you write beneath as if you're writing a base. F subscript 7, factors of 7, and so on and so forth. So the factors of 4 now will be 1, 2, 3. That is 1 times 4, and then 2 times 2. The numbers multiply to get 4. The factors or the divisors. Factors of 5 are 1 and 5. Numbers multiply to get 5 are 1 and 5. Or the divisors of 5. 5 divided by 1 is 5. 5 divided by 5 is 1. Like that. So that's how you can get the factors of 7, factors of 8. So what are prime factors? Prime factors are the factors that are prime numbers. When they tell us example, prime factor is 108. That means they want us to write 108 as a product of its prime factors, or you can just list the factors as we are going to see in our calculations here. So if you want to get the factors of 108, you can as well this one is trying to move, so I can put it back. If we talk about factors of 8, we can use what we call the ladder method. And then you have the prime factors here, and then 108 here. So the first prime number will be 2. 108 divided by 2. 108 divided by 2 is 54. 54 divided by 2 is 27. Then you move on to the next prime number, which is 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So it has all been reduced. Now it means you have these ones written as the prime factors. 2, 2, 3, 3, 3. Or when you want to write them as a product of the prime factors, you multiply 2 times 2, 3 times 3 times 3. Or 2 power 2 times 3 power 3. So those will be giving you the prime factors of 0.08. Example 2, prime factorize 18. You can do the same thing. You get prime factors and then 18. The first prime number is 2. 18 divided by 2 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. Then you can list them as 2, 3, 3. Then we also have what they call the greatest common factor. Now the greatest common factor or the highest common factor, you can use H.C.F or H.C.F. This is a factor that is going to be common among a list of factors for the given numbers. There's the highest common factor between 4 and 6. That means you can list the factors of 4 and factors of 6 and find the greatest common. So you have listed factors of 6 are 1, 2, 3, 6. Factors of 4 are 1, 2, 4. And the greatest common factor here can be got by either listing and set with the greatest common factor, or you can use the ladder method. Prime factors of 4 and 6. So the greatest factor here, which can divide through 4 and 6, is going to be 2. Going to divide, the other number can divide through all of them. So 2 will be the answer. You can use either the ladder method or you can list them. Then we have what we call the multiples of a number. So when they talk about multiples of a number are got after multiplying the natural number by 8. Like if you do not my, denoting multiples of y, then m2 can be multiples of 2, m3 multiples of 3, m4 multiples of 4. If you write the subscript, right, it can stand in for the multiple of that particular number. So multiples of 2, that means 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8, 2 times 5, 10, 2 times 6, 12, 2 times 7, 14, like that. Then you can do the same thing, multiples of 3, 3 times 1, 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12, like that. So that gives you the multiples of the number by listing. And lowest common multiple, this is also going to be the number that is going to be the smallest common in the multiples that you have given in a list. You can also use the ladder method if you don't want to list. For such big numbers, you can use the ladder method. But if it is multiples between 4 and 6, you can list them and find the lowest common. So if you list multiples of 4, 4, 8, 12, 18, 20, 24, 28, 32, 36, and multiples of 6, 6, 12, 18, 24, 30, 36, 42, 48, you can see that the lowest common to them is 12. So that becomes the L.C.M. If you use the ladder method, here, that means that you write the prime factors, write 4 and 6, then start with the first prime number, which is 2. 4 divided by 2 is 2, 6 divided by 2 is 3. So you continue with the 2 because 2 can still divide here. So 2 divided by 2 is 1, 3 divided by 2 it can't, you leave a 3 there. Then move on to next. Next prime number is 3. 3 divided by 3 is 1, so everything is reduced to 1, 1. So the L.C.M will multiply these prime factors given here, 2 times 2 times 3, which gives you 12. So that is the ladder method that we can use for that question. So as we go for our small break, you can try another example where they say, determine the smallest sum of money out of which a number of men, women, and children may receive $75, $90, and $120 each. So that means they're asking you indirectly. This is an application. So if they ask you indirectly, you can do this by using the ladder method, and you're going to determine the L.C.M. You're going to use your ladder method, start with the 2, divide through, and you find it can divide through here. But if it's 2 cannot divide through the numbers, then you move on to 3, and then move on to 5. Then you find that your prime numbers are 2, 2, 2, 3, 3, 3, 3, 5, 5. So that is 2 to the power 3, 3 to the power 2 times 5 to the power 2, which gives you $1,800. So that can take us to a quiz. This is our second quiz in this module. And in this quiz, they're telling you find the greatest common factor between 28, 35, and 70. Then what is the LCM between 10, 12, and 18? Then number 3, 3 rods of length 216 centimeters, 288 centimeters, and 3.6 meters are cut into pieces of the same length. Find the greatest possible length, which can be cut without leaving any remainder. Determine the smallest sum of money out of which a number of men, women, and children may receive $75, $90, and $120 each. Prime factorize 100 and hence find the square root of 100. So you can try to pause and do those questions. And if you're struggling, we have the solutions for you here. The highest common factor between 28, 37, and 70 is 7. So you can use the ladder method and get your answer 7. The LCM between 10, 12, and 18 is 180. And you can still use your ladder method to get that answer. The possible length is 72. To get this length, make sure that all the length are put to centimeters, and then you can use your ladder method. The amount we talked about here, you also use the amount that can be shared. You're going to use the ladder method and use the prime factors. So you get $1,800. Then finally, the prime factors that we are looking for 100 at 2 power 2 times 5 power 2. Hence the square root, that means you're looking for which number has been squared. That is the same meaning as square root. So the number that has been squared is 2 and 5. When you multiply, you get 10. So that's how you can do that. So we are going to end our discussion there. We shall come back after the break and look at the second part, which is talking about divisibility tests. Hello. As we resume from our introduction, we are resuming from our introduction. Hope we are together. And in this discussion now, we want to talk about divisibility tests. Okay. So, we're going to talk about divisibility tests in this second session of our discussion. And what do we mean by divisibility tests? In divisibility tests, we can see that actually, this is our topic in number 4. A number is divisible. We are going to look at the test by telling whether a number is divisible. So the kind of procedures we follow in order to tell whether a number is divisible are the ones we are calling the divisibility tests. Like if a number is divisible by 1, that one is obvious. Every number is divisible by 1. No number will not obey that. But when you talk about divisibility test of 2, a number is divisible by 2 if the last digit is an even number. If we have the last digit is, let me say, is 2, is 0, is 2, is 4, is 6, is 8. So long as it's an even number, that number will be divisible by 2. Then a number to be divisible by 3. A number is divisible by 3 if the sum of the digits making that number is a multiple or divisor of 3. To say, if we have 1002, that's 1002. That means you say 1 plus 0 plus 0 plus 2. It gives you a 3. So which means 1002 is divisible by 3 because you are getting a 3, and 3 is a divisor of 3, or is a multiple of 3. So when you divide 1002 by 3, you're going to get 334. You can do the same, check with 2004. When you add up these digits, you get a 6, and 6 is a multiple of 3. 5 plus 0 plus 0 plus 4 is a 9. So 9 is a multiple of 3. 6 plus 4 plus 2 is 12. And 12 is a multiple of 3. Like that, like that. The divisibility test of 4. If a number is a number formed by the last 2 digits are divisible by 4, then the whole value is divisible by 4. Also, if the number can be divided by 2 twice, remember, to be divisible by 2 must be an even number. So if I have like a number like 104, the last 2 digits is 4, which means that one is a divisor of 4 because 4 is a multiple of 4. If you have 1, 2, 2, 2, 2, 4, 2, 4 is a multiple of 4, so it is divisible by 4. 1, 8, 8, 8, and so on and so forth. When you divide 200 by 4, you'll get 50 because 200 divided by 2 already is 100. 100 divided by 2 again is 50. So you can divide it by 2 twice. Divisibility test of say divisibility test of 5, 6, and 7. A number is divisible by 5 if the last digit is a 0 or a 5. Like 1,000, 245, 5555, all those ones are going to be divisors of 5 because the last digit is a 5 or is a 0. Divisibility test of 6. A number is divisible by 6 a number is divisible by 6 if it can be divisible by both 2 and 3. It give 162, 198. That means you check whether it is divisible by 3 by summing up the digits. If you sum up the digits and find the multiples of 3, then it is divisible by 3. Or if you find it has a last digit has even number, it's divisible by 2. So if it obeys those 2, if the 2 hold, then it is also divisible by 6. And now a number is divisible by 7 if the last digit doubled and you subtract the first 2 digits will give you a multiple of 7. What do we mean here? If I have 119 as an example, to check whether it is divisible by 7, 9 times 2 is 18. That's the last digit. Now 18 subtract 11, those are the first 2 digits. 18 divided by 11 is 7, and 7 is a divisor, is a multiple of 7. So that is how we can check for the divisibility test of 7. Now to check divisibility test of say 8, 9, and 10, let us start with 8. If you want to test for divisibility test of 8, a number is divisible by 8 if the last 3 digits are zeros. There are 3 zeros. The last 3 digits are all zeros. You can set it divisible by 8. Ig, 1,000 is divisible by 8. Because 1,000 divided by 8, you get 125. You can also check divisibility test of 8 by finding out whether it is divisible by 2 and 4. When is the number divisible by 2? We talked about that. Or it is divisible by 2 thrice. You can also find out using that idea. You find whether it's divisible by 2 if the last digit is an even number. Or divisible by 4 if the last 2 digits are multiples of 4. Then divisibility tests, you can look at more examples here as we have listed them. Divisibility test of 9. A number is divisible by 9 if the sum of its digits is divisible by 9. It is so much similar, like this is the test of 3. Or you can also find out if it's divisible by 3 thrice, or I mean it twice. Then it's also divisible by 9. You can check with 81, those kind of numbers. Check with 18. If you sum up the digits, they give you a multiple of 9 and so on and so forth. Divisible test of test is our last one. The number is divisible by 10 if the last digit is a 0. I think that can be so much obvious. We can move on to a small quiz here. Can move on to a small quiz. And our quiz is saying, show that 144 is divisible by 2, 3, 4, 6, 8, 9, and write down their respective quotients. To find whether a number is divisible by 2, 3, 4, 6, 8, and 9, we can use our tests that we have been carrying out. And also to find whether, in the second question, they're telling us to find whether 119 is divisible by 7. So to find whether a number is divisible, we can look at some of the solutions we have here. If you test 144 by 2, you see the last digit is an even number. So automatically it is divisible by 2. And when you divide by 2, you get 72. To find whether it is divisible by 3, you sum up 1 plus 4 plus 4, you get a 9. 9 is a multiple of 3, so it is divisible by 3. And when you divide by 3, you get 48. To find whether it is divisible by 4, so the last 2 digits are 44, which means those ones are multiples of 4. You know 44 divided by 4 is 11. So the quotient of 144 is going to be 36. Quotient of, when you divide by 4, you're getting 36. To check whether it's divisible by 6, you can see it has been divisible by 2 and also it has been divisible by 3. So automatically the quotient is going to be 24. Find whether it is divisible by we are moving on to which one? 9. So the quotient is going to be 16 because when you sum of those numbers, you're getting a 9. Then this 119, we have already checked it. Multiply the last digit by 2, then subtract 11, you get a 7. So the quotient of when you divide that number, you can get your quotient as what? What is your quotient? So you can try out that. And then we can move on to our 5th topic. The 5th topic is talking about integers. Integers are positive and negative numbers, including 0. So if you list them, if you look at negative 5, negative 4, negative 3, negative 2, negative 9, 0, 1, 2, 3, 4, 5, 6. The list is endless on both sides. And integers can be represented on a number line. That is an horizontal line showing equal spread out of the numbers in equal increments. Operation on integers include addition, subtraction, multiplication, division. When you talk about addition, when you add a positive to a positive, you get a positive. When you add a positive to a negative, you might get a positive or a negative, depending on whether the negative is so big. If the negative is so big and you add it with a positive, automatically you get a negative. But if the negative is too small and add it to a positive, you'll get a positive. Then with subtraction, if you subtract a positive from a positive, depends on what you're subtracting. If your subtraction is big, a big positive, subtracting from a small positive, then you get a negative. So which means the answer can be positive or a negative, depending on the size of the number you're subtracting. Then when you subtract a minus, subtract a positive, automatically must get a minus. A minus, subtract a positive, must get a minus. Then a minus, subtract a minus, can be minus or positive, depending on how big the negative is. If you are subtracting a very big negative, minus a very big negative, you get a positive. Minus a smaller negative, you will get a negative. Then multiplication and division will work in the same way. When you multiply same signs, you get a positive. That is negative times a negative is positive. Positive times a positive is a positive. When you multiply different signs, you get a negative. So negative times a positive is a negative, or a positive times a negative is a negative. So the examples you can try, simplify the following. Positive 4 plus positive 6, minus 4 or negative 4 plus positive 6, negative 4 plus negative 6, negative 4 minus positive 6, minus 4 minus positive 6, minus 4 minus 6, positive 4 times positive 6, negative 4 times positive 6, minus 4 times negative 6. So if you try these examples, now solutions shall remember that positive 4 plus positive 6 is going to be positive 10. Negative 4 plus positive 6 is going to be positive 2. Because you see, you are having a small negative and a big positive, so you have to get a positive. Negative 4 plus minus 6. So a negative 4 plus a negative 6 is a negative 10 because you're adding negatives. Positive 4 minus positive 6, you get a negative 2 because now you are subtracting a big positive from a small positive. And then negative 4 plus negative 4 minus a positive 6 is going to be negative 10. We said if you are having a minus and you subtract a big positive, you have to get a big negative. Negative 4 minus 6, that's positive 2 because now you're having a small negative and you're subtracting a big negative and get a positive. Then positive 4 times positive 6 is positive 24. Negative 4 times positive 6 is negative 24. So you're seeing same signs multiplied, you get a positive. Different signs multiplied, you get a negative. Like that. So different signs multiplied, negative, positive. Same signs multiplied, you get positive. Then our quiz is simplify negative 2 plus 6. Positive 6 minus 6. Positive 8 divided by negative 2. Negative 5 times negative 3. Negative 3 minus 7. That is our quiz you have to try and see what answers you're going to get. So you pause a little bit and try it. And if you're still struggling, we can help you with the answers. But if you have the answers are there, but of course, if you say negative 2 plus 5 plus positive 5, you get a positive 3 because you're having a small negative and a big positive. Then positive 6 minus 6 because you're having a positive 6 minus. These negatives multiply and you get a positive, so which means when you put them closed, that's as if you're saying positive 6 plus 6, which is a 12. And then because you are dividing positive 8 divided by negative 2, you have to get a negative 4. Why? Because different signs multiplied, you get a negative. So when you divide, it's the same thing. And then negative 5 times negative 3 is positive 15 because same signs multiplied. And then negative 3 minus 7, so it is going to be positive 4 because you're having a big negative subtracted from a small negative. So that is it. Our next topic moves on to number bases. That is topic 6. A base is a number of unique digits, including the digit 0, used to represent numbers. Okay? So examples, if you look at base 10 or the denary or decimal system, as our usual counting numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Base 9 or the nonary includes 0, 1, 2, 3, 4, 5, 6, 7, 8. So you must not include that number. If you're in base 9, you can't include 9. So 9 will become 1, 0. Because you have to divide 9 by 9 and you get 1 remainder 0. Base 8, the octal number system includes 0, 1, 2, 3, 4, 5, 6, 7. And then base 7 or the other septenary is 0, 1, 2, 3, 4, 5, 6. Then base 6 for the senary or H.C.M is 0, 1, 2, 3, 4, 5. Other bases, you have base 5, which is the pental system, number system. Base 4, the quaternary number system. Base 3, trinary number system. Base 2, the binary, and so on and so forth. Base 12, your decimal, and so on and so forth. So you can have all those as examples of bases by showing the number system they'll have. Now you can move on and look at what we call addition of bases. If you're adding bases, you'll add, and if the value is bigger than the value of the base, you have to divide by that base, and then carry the whole number, leave the remainder behind. So if you try to add, for example, 8, 9, 7, and 9, 2, 6, 5 in base 5, I mean in base 10, as you see this number. So if you want to add it in base 10, which means you'll add 7 to 5, which is 12. So leave 2 as a remainder, because 12 divided by 10 is you leave 2, then carry the whole number 1. You get it? Then you say 9. You have, 4. This number was 8947, sorry. So if you add the 4 to a 6, it is 10, but remember you carried the 1. So that makes it 11. So 11 divided by 10 is one whole number, carry 1. So you add the 1 to the 9. 9 plus 2 is 11, but remember you carry the 1, so it becomes 12. Still 12 divided by 10 is 2, carry 1. 1, you're adding to 8. So 8 plus 9 is 17. Adding on the 1 becomes 18. So you can write your 8, carry 1. So when you add all things, it becomes 1, 8, 2, 1, 2. So that's how you can add such in base 10. You can try some more examples here. And you're trying to add, for example, into a decimal. You're adding A3 T2T to 15461. So if you add this, do the same thing. You're adding 1 to T. T stands in for 10, because in base 12, you can only write 10 as a T. You can't write 1, 0. It doesn't work. That only works in base 10. So if you add T, you arrange your number E3 T2T and then 15461. So arrange those digits, and then when you try to add, you're going to get 10928 in base 12. Example 3, you can also add in base 11 the same thing, 15728, add 3461. And when you add that in base 11, you're adding this time 3 digits at once. You're also adding 7928 base 11. And when you add that, you're getting 10289 base 11. So you can also try to practice that. Subtraction of bases. We can subtract bases using our usual ideas, as we see in the subtraction. That means you subtract. If the number is really less than the base, less than the value you want to subtract, you must borrow, as we do in our base 10. You borrow, but this time you borrow a value equivalent to the base. If you try to subtract, for example, in base 10, We have 7351, 4126. If you subtract that number, remember, 1 subtract 6 doesn't come. So which means you have to borrow. You borrow from a 5. Now when a 5 you borrow 1, it comes to 1 as a 10. So you say 10 plus 1 is 11. And 11 minus 6 now works. 1 minus 6 will not work. But now 11 minus 6 can work. And you get 11 minus 6 is going to be a 5. So that's the idea we use. Then, because you already reduced 5 to a 4, so 4 minus 2 is going to be a 2. Then 3 minus 1 is a 2. And then like that. So that's the idea we are supposed to use. And then you get your final answer as we have written it here. So the final answer will be written like that. Okay, so you can use those ideas to do a variety of questions here, as we are going to see. They're telling us to subtract in base 5. This time they're putting in decimal points. 141.143 base 5. Subtract from 30.241 base 5. So you can try it and see whether you get the same answer as ours here. Because when you subtract, you must get 11.043. Then they're also giving us another one, subtract in base 6. 4.304. 4.30. Write this one. 4.30, yes. You're subtracting 3.52 in base 6. And you must get your answer as 0.34 base 6. Okay? So those are some simple examples. But remember, in base 6, that means when you borrow, you're going to carry the value, that value you have as a 1, you carry it as a 6 because it's in base 6. The same thing if you're in base 5. If you borrow, you carry that value as in base 5. You carry it as a 5, not like the way you did in base 10, because the values must change. Now, how do we convert how do we convert to base 10? Or how do we expand the bases? Now, when you want to expand, you're going to use ideas of place values, which means that when they tell us to convert 101 base 2 to base 10, if you look at 1, space value is going to be a 0 here. So because it's base 2, we can't say 1 was, okay, they're all 1 was, as you know, as you see it in base 10. But now you can say power 0, power 1, power 2. Let us just use those powers. Of course, they will mean the base. If it's base 10, somebody can say 1 was 10s, 100s. But now it's base 2, which means somebody can say 1 was, then you go to, let me say 2s, then it goes to 2 2s. See that, which is like a 4, like that. So we just use the power 0, power 1, power 2. So when you're expanding this, 101, it's going to be 1 times 2 power 2, plus 0 times 2 power 1, plus 1 times 2 power 0. So we carry that value of the base, as we have talked about your base 10. Now we are talking about base 2. Because when you carry the value of the base, let me say base 10, you have seen 1s, 10s, 100s. Now it is in base 2, it's 1s, 2s, 2 2s. You see that? So that is 1 times 4 plus 0 plus 1. Because n number to power 0 is a 1. And number to power 1 is that number. So our value is 5 base 10. Let us to change 5t base 11 to base 10. Now the same thing, this power 0, t is power 0, and 5 is power 1. So 5 times 11, because the base is 11, 5 times 11 power 1, plus t times 11 power 0, which is equal to 5 times 11 plus 10 times 1, because you have said the number to power 1 is that number, the number to power 0 is a 1. So you get 5 times 11 is 55 plus 10, which is 5 base 10. Okay? So that's how we can get our answers in base 10. Now, when they tell us to convert from from base 10 to another, that means this time we're going to use a small table here. And in our table, we shall have the base wanted, BW. Then we have base 10, base wanted, base 10, and then we have the remainders. So if you look at the values you're talking about here, if you talk about the values here, you're looking at really converting 841 base 10 to base 12, or to a decimal, which means just say 841 divided by 12, which gives you 70 remainder 1. Then 70 divided by 12 is 5 remainder t, or remainder 10, in other words, because we are not going to put 10 there, we shall put a t, this is base 12. So our answer is read from down up, which is 5t1. So that is how we can convert to base 12. We can try other bases. That is changing from any base to another. Whenever you're changing from one base to another, we must first change to base 10. Then we move on to our table that we have talked about. Example, if you tell us to change 5.3 base 7 to base 5, we first change 5.3 base 7 to base 10 by expanding. So 5.3, 3 is power 0 and 5 is power 1. So 5 times 7 power 1 plus 3 times 7 power 0, which is 5 times 7 plus 3 times 1, which is 35 plus 3, which is 38. So 38 in base 10. Then 38 in base 10, we can now convert it to the base wanted. So base wanted, base 10 remainders. 38 divided by 5 is 7, remainder 3. And 7 divided by 5 is 1, remainder 2. So you can read our answer from down up and read only the remainder, so which is 1, 2, 3. So that is the answer. It's going to be 1, 2, 3, base 5. So in other words, we have converted from base, from the base, which was base what? We are converting 5.3 base 7 to base 5, and we get our answer as that. Okay? So you can try many examples. You can also solve unknown bases. Like they're giving us 2, 4 base n is equal to 5, 2 base 10. Now to do that, we put everything base 10. That means we shall expand 2 for base n. We're going to expand 4 power 0 and 2 power 1. And our 2 times n power 1 plus 4 times n power 0, which is going to be equal to 5, 2. Now, because n number power 0 is 1, so we have 2n plus 4 equal to 52. Subtract 4 both sides, and we get 2n is equal to 48. 2n is equal to 48, divide 2 both sides, and we shall get the value of n. If you look at this, I think here there's this one, try to skip off, but you can see that our n is going to equal to 24. So just for the sake of academics, we can say the base is 24, but no, that's the value of n. So you can try a quiz. They're telling us to solve 1110 binary to base 8. Also change 2t to a decimal to binary. Find the difference between 2, 3 base 4 and 1, 1 ternary and ternary number system. The final answer, they want it in a ternary number system. Then another question you're saying, find the sum of 3, 3 base 5 and 1, 0, 1 binary, all decimal number system. So you can have the answers to the quiz, or you can first pause and try it before you can really come up with the answer. And first try it before you can really switch on to get the answer. So to do that, we are going to say first change to base 10. So you put powers, power 0, power 1, power 2, power 3. So 1 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 plus 0. Because 0 multiplied by anything will still be 0. So you get 8 plus 4 plus 2 plus 18, because 2 to power 3 is 2 times 2 times 2, as we say. 2 power 2 is 2 times 2, and 2 power 1 is 2 times 2 is 2 power 1 is still 2. So that is 8 plus 4 plus 2, which is 18. And then you can, after changing base 10, you can now change to base 8 by using our table. Base wanted is base 8, base 10 is 18, and the remainder is 2. So 18 divided by 8 is 2 remainder 2. So our value is 2 base 8. You can do the same thing to t base 12 by expanding, and then after we change the answer to binary. After getting base 10, change to binary. Convert this one base 3 to base 4. So when they tell us to get the difference, make sure to put them in the same base, and then we subtract. So here, they put them all to base 10 and subtracted. Oh, no, they were all put, you have 1 base 3 to base 4, which gives you 4 base 10, then 4 base 4 is 10. So put them all to base 4, and then subtract, and we got our answer as 1, 3. And then finally, 3 base 5, 1 6 base 10, then 1 0 base 2. And then you can sum up and you get the answer as to 1 base 10. So that is it for our quiz. So you can try them many times so that at least you can do that. Multiplication of bases. When multiplying any base, do it normally as in base 10, but divide the result by the base given. Then write the remainder, carry the whole number. If the number is large, the final value will be summed up. Keep on adding up the values. I think we need to try this. 231 multiplied by 24 in base 5. So what we can do here is that we can try to multiply this number as you see. Sorry for that. So we have we are talking about the multiplication still. We have not gone to division. Okay, the question is here, the solution. So we multiply 231 by 24 in base 5. So you can see this is how we multiply it, and then we shall get our answer like that. Then when they tell us division, we can do the same thing. If they tell us to divide this in binary, we can first put everything in base 10 and then divide that value in base 10, because we enjoy using base 10. Then after we can convert back to binary. I think that will be easier. So we convert this one to base 10, this one to base 10, and then the final answer converted back to binary. So that is what we do here. When you divide 44 by 4, you get 11, and then you can convert 11 back to binary and get our answer as 1011. That is, the answer is in binary. Okay, so we have a quiz. Divide 205 by 15 by 15, or in base 6. Divide 15 base 12 by 17 base 10. The final answer, base 4. Then 2003 base n is equal to 57 base 10. Find n. So for y, if 204 base y is equal to 36 base 10, multiply 111 by 2. I mean multiply 1111 base 2 by 111 base 2. So you can try that quiz, and then you shall get the solutions to the quiz, and then we can really meet in our next discussion. So that's the solution to the quiz. You can try them, and then we shall meet in our next discussion, where we shall talk about the fractions as our almost topic that is going to come up later in our discussion. So we are going to come up with that later. Thank you. Hello. I welcome you back to our last part of this module, and I'll take you through basically fractions. Then we shall also look at decimals. Then we shall bring in what we call the percentages, and then we finish with the ratios. So those are not going to be so much for our discussions. So we can move through this very fast, and then we shall be done. As we ended up the other time, we had talked about some few ideas. Now, what are fractions? A fraction is part of a whole number. Example, if you cut a circle into 2 equal parts, you get a half, which means 1/2. So you can see we are cutting the circle into 2 parts, into equal parts. So the number that appears above the line here is the numerator, and below the line is the denominator. Let us try another illustration that if we have a rectangle and we cut it into 4 equal parts, if we shade one part of the rectangle, it gives you 1/4. The unshaded gives you 3/4. So the 1/4 represents a quarter. So which means that you have 1/4, where 1 is the numerator and 4 is the denominator. And when you say 3/4, you have 3 the numerator, and then 4 the denominator, which is 3/4 or 3/4. Okay? Then we can also look at how can we add fractions. Before we go to the addition, we have the types of fractions. We have those we call the improper fractions, proper fractions, and mixed fractions. The proper fraction is a fraction whereby the numerator is smaller than the denominator, say 2/3, or 2/3. Improper fractions are fractions where the numerator is greater than the denominator. So the number above the line is more than the number below the line. So 4/3 is an example of an improper fraction. Then a mixed fraction is a fraction whereby you're having a whole number combined with a proper fraction. Example, you can set all numbers under 5. So that is a mixed fraction. How can we change from one type of fraction to another? So to change from one type of fraction to another, it depends. If you are changing from improper fraction to a mixed fraction, example, we tell you to change 27/5 to a mixed fraction. So what you do here is you can have 25, because when you check 25 divided by 5, 25 divided by 5, say 25 divided by 5, you get a 2. So which means there's a remainder of a 2. So that goes to 2 sorry for that, 2 whole numbers, and then 2 over 5. So that means you're going to get 2 whole numbers and 2 over 5. That is how you can come up with that. Then if it is the same, changing from a mixed fraction to a proper fraction. How do we do that? We're changing from a mixed fraction to a proper fraction. Okay, something I think I've deleted here. So I'll need to undo it. So if you're changing from a mixed fraction to an improper fraction, you're going to multiply the numerator with the denominator with the whole number, and then add the numerator. Yeah, I deleted it, but okay, we're back. So if you are changing 6 whole numbers over 9 to an improper fraction, you can say 6 times 9, then you add the numerator, which is 4. 6 times 9 plus 4 is 54 plus 4 is 58. So you get a new numerator, and then you can divide with the original denominator. So that makes it 15/8 over 9. Okay. Then how can we deal with simplifying fractions? Simplifying means that you're writing a fraction in its lowest form or a reduced form. So whenever they say simplify, you're putting in a reduced form. Like somebody giving you simplify 10 over 96, which means you look for the common divisor that can divide 10 and 96. So you can take up, say, 2. 10 divided by 2 is 5, and then 96 divided by 2 is 48. So it becomes 5 over 48. Then they say reduce 72 over 80. You do the same thing. What is the common divisor there of 72 and 80? So you can take up, say, if you can get a quick one, like 4, 72 divided by 4, that gives you, say, 18, and 80 divided by 4, it gives you, that means 20. Then you can still reduce. 18 divided by 2 is 9, and 10 divided by 2 is 10. So you can reduce it up to 9 over 10. So which means somebody would have taken up, let me say, the best there to divide with would have been 8. Because 70 divided by 8, you're getting a 9, and 80 divided by 8, you're getting 10, and so on and so forth. So you can also try 108 divided by 100 and see what you're going to get by using that method. Okay, how do we solve for the unknowns in fractions? If you have to solve for the unknowns in fractions, for example, if somebody gives you to solve for x, and you're given 2 over 5 is equal to x over 12. So what do? You cross multiply. See, you cross multiply. How do you cross multiply? You're going to multiply, that is 2 times 12 and then 5 times x. If you do that, you have cross multiplied. The 2 is multiplied with the 12, the numerator is multiplied with the denominator, and then the other denominator is multiplied with the numerator. So that gives you 5x is equal to 2 times 12, which is 24. Then when you divide both sides by the 5, sorry, that gives you x is equal to 24 over 5. Okay, so how do we write the fractions in increasing or decreasing order? So the increasing order is called ascending order, and then the decreasing order is called the descending order. Example, they're telling us to write 1 over 2, 2 over 3, 1 over 6, and 3 over 4 in ascending order. So if you are to write in ascending order, we need to first get the L.C.M between the denominators. Then multiply that L.C.M on each of the fractions, like a half. And now our L.C.M is 12, get 6. 2 times 12, you get 8. 6 times 12, you get 2. And 3 over 4 times 12, you get 9. Which means you look for which one is the smallest value, and then you write them in increasing order. Write the fraction in increasing order. So yeah, the smallest value is 2, which means a 6 should be a first fraction. The next is 6, which means a half is the next fraction. And then move on to 2/3, and then finally 3 over 4. So that is the increasing order. You can also reverse and write them in descending order using the same method. Start with the biggest, then go to the smallest. Okay, how do we add fractions? If you're adding fractions, we can still use our idea of L.C.M. If they tell us to add 5 over 6 plus 1 over 4, you can get the L.C.M between 6 and 4. Then you divide the L.C.M by the first fraction denominator, and then multiply with the numerator. So that is, if our L.C.M is 12 over here, so 12 divided by 6, you get a 2, multiplied by 5, that means 2 times 5, you get 10. Do the same thing, 12 divided by the next fractions denominator, which is a 4. When you divide 12 by 5, you get a 3, then multiply by the numerator, which is 1. So that means 10 plus 3. So you're going to add up, and then you get 13 divided by 12. So that means our new fraction is 13 over 12, which is another number, 1 over 12. Okay? So we can try another. If they tell us to add 4 over 7 plus 2 over 7. Now, since the denominators are the same, this time you don't need to disturb yourself getting L.C.M. You just add only the numerators and divide by the original denominator, which is 7. So that gives you 4 add 2, just add 4, the numerators, 4 plus 2 over 7, which is 6 over 7. When they tell us to add to all numbers, 2 over 3 plus a half, we can try to first get the 2 and 2 over 3, that mixed fraction, and write it as an improper fraction. Then continue getting the L.C.M, which is 6 between the denominators. Then multiply the L.C.M by the first fraction, which is now, that is our new fraction. If you written that improper, 2 and 2 over 3 as a fraction becomes 8 over 3. So you can now look at our addition by now saying 8 over 3 add on a half. So our L.C.M being 6, because 3 and 2, the L.C.M is 6. Then say 6 divided by 3 is a 2, then multiply it to 8. Plus 6 divided by 2 is a 3, then multiply it to 1. Then you can get 16 plus 3 giving you 6. Then to use our new fraction as 19 over 6. Okay? So you can move on and try another concept, which is subtraction of fractions. How do we subtract fractions? The method is the same as the one we have used in our addition, but this time it's only the sign changing. So get the LCM between the fractions, between the denominators of those fractions. So they tell us to work out 2 over 5 minus 1 over 6. LCM between 6 and 5 is 30. So which means 30 divided by 5 is going to be 6 times 2 minus 30 divided by 6. It gives you 5 times 1. So which means 12 minus 5 is going to be 7 over 30. So we have a quiz here. Add 1 over 2 plus 1 over 4 plus 1 over 8. Then find x if x over 6 is equal to over 3. Then also simplify final number the half minus a quarter. Then lastly 8 over a is equal to 4 over 5, but find the value of a. So we can solve this question if we use our ideas I've just talked about. So which means in your solution, get the LCM between the denominators, which is going to be 8. Then when you divide, multiply, you're getting 4 plus 2 plus 1, which is 7 over 8. Then the other one, we are cross multiplying. When you cross multiply, you have 3 times x, and then also you have, if you look at your fraction here, you're saying 3 times x, and then 6 times 2, which is 12. So that means you're getting 3x equal to 12. Then divide both sides by 3, and you get your answer, x is equal to 4. So here you have written 2 whole numbers and 1 over 2 as 3 over 2. Then subtract a quarter, which is now LCM between 2 and 4 is 4. Then you divide by 2, you get a 2 times 3, 6. Then subtract it 2 and you get 4 out of 4, which is 1. Then do the same thing, cross multiply in the last question. And then you get 40 equal to 4a. Then divide both sides by 4, and you end up getting the value of a as 10. Multiplication. How do you multiply fractions? You multiply fractions if you multiply the numerators alone and also multiply the denominators separately. I know this. That means you're going to have 2 multiplied by 3 and then 5 multiplied by 5, which gives you 6 multiplied by 5. That's a simple idea you can use. Just multiply the numerators and also multiply the denominators separately. Then how do we use of? So of is used as multiplication. They tell you a half of 2 over 3. That means you say 1 times 2 and then 2 times 3, which gives you 2 over 6. You simplify further by 2 and then by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3, and you get a third. You have to simplify the reduced form. Division of fractions. How do we divide fractions? Now, if you're dividing fractions, still shall use our idea of multiplication. Change the sign to the say divide 1 over 8 divided by 1 over 2, which means you're going to change the sign here of division, which is in between them, and then change the next fraction. How do we change the next fraction? The one which has been the numerator becomes the denominator, and the denominator becomes the numerator. In other words, you say you reciprocate it. So if it has been 1 over 2, it becomes 2 over 1. And then you say 1 over 8 times 2 over 1, which is 1 over 8 times 2, which is the same thing as 1 times 2 over 8, which is going to be 2 over 8, which is simplified as a quarter. Okay? Hope we're moving together. You're not asking for a break yet. Then we can move on to our quiz here. They tell us a third of the class of 33 are boys. How many are girls? Then 2. Out of a group of 60, 42 comes 3. What fraction is this? Then simplify it over 5 times 5 over 7. Then simplify 11 over 4 divided by 11 over 8. How do you deal with that? So you can try it before I can take you to the solutions. So if you say a third of a class, a third of a class of 33 are boys, which means you can say a third of 33, which means you're going to multiply. A third of 33 is 11, and that gives you 11 boys. So to get the girls, you can just say the 33 subtract 11 and then get 22 girls. When they say 42 out of 60, that's the same thing as simplifying it as 21 over 30. Then the other question was saying, simplify it over 5 times 5 over 7. So we shall multiply 2 times 5 and then 5 times 7. And you get 14 out of 35, which you can reduce by 5. 14 divided by 5 is 2, and then 35 divided by 7. So 14 divided by 7 is 2, and then 35 divided by 7 is 5. And then lastly, 11 over 4 divided by 11 over 8. We're going to use our idea just talked about, that you say 11 over 4 times 8 over 11. So which means you can even cross out the 11s, and you can cancel them out, and you remain with 8 over 4, which is going to be 2. Okay, how do we combine signs? We can combine signs using what we call body mass, brackets of division, multiplication, addition, and subtraction. So you're going to deal with those signs in that order if the signs are mixed up or are combined. We can try an example here. If they tell us to simplify one whole number, a half minus a quarter plus 2 over 5. And then in brackets, 3 over 4 of 2 whole numbers and a half, subtract another bracket, one whole number a 6 divided by 2 whole numbers and a 5. Then 1 over 6 minus 2 over 9 times 7 over 8. So they are combining signs here, and you have to use body mass. So if you want to look at the solution for that, it means we can first look at the first example. We have changed this to an improper fraction, whereas one whole number and a half, so now it is 3 over 2 minus a quarter plus 2 over 3. So because body mass says addition first, we shall start with addition and then end up with subtraction. As you see, A and S coming last here. So we can say 3 over 2, you add 2 over 5. The common mistake, members want to start adding these ones. This one, they can't add a quarter plus 2 over 5. No, you deal with the positives first. So as we saw in the integers. So the best thing is they can say 3 over 2 plus 2 over 5, and then you get your L.C.M, which is going to be 10 divided by 2 is 5 times 3, 15, and then 10 divided by 5 is 2 times 2 is 4. Then sum them up, then 19 over 10. Then you subtract last. It's 19 over 10, now you can subtract your quarter. So that's how you can arrange them. And you can still get your L.C.M as 20 between 10 and 4. And then divide 20 by 10, get 2 times 19, 38. And then you subtract, get 33 over 20. Hope we are moving well. We can look at another working for question 2 and 3, whereby you have 3 over 4 of 5 over 2. We have changed one into a fraction, and then minus 7 over 6 times 3 over 7. So if you look at O, we said we use that multiplication. So when you use over as multiplication, it is going to give you 5 times 3, which is 15, divided by 4 times 2, which is 8. Then subtract. Here you are simplifying. When you say 7 over 6 times 3 over 7, the 7s Since the 7 is a numerator, another 7 is down, you can cancel them. And then you remain with 6 divided by 3. It's going to be a half. Then when you subtract this, the LCM is 8. So you end up getting 15 minus 1. And 15 minus 4 divided by 8, which is going to be the number 8. Do the same thing in the last question. Remember, they wanted us to look at 1 over 6 minus 2 over 9 times 7 over 8. So you're going to use your body mass, and multiplication comes first. When you deal with the multiplication first, that means the last part of the fraction don't have multiplication, it gives you a third, and you have 1 over 6 minus. 1 over 6 minus, I mean 1 over 36, not a third, 1 over 36. So when you deal with your subtraction, LCM is 36, and you get 30 over 36, which is 5 over 6. You see it. Okay, so we can move on to decimals. We can move on to decimals if all is okay. So in decimals, what is a decimal? This is our almost second last. A decimal is noted by having an integer separated from a non-integer by a point in between. So if you say 4.6, that means 4 is the whole number, and then the 6 is a fraction. It's a non-integer. So there are mainly 3 types of decimals. These include recurring decimals, terminating decimals, and decimal fractions. So we're going to just deal mainly with the recurring and the terminating decimals, or the non-recurring decimals. A recurring decimal is one with the digits being repeated or repeating themselves. Like somebody can say 0.333 and so on and so forth. Those are minutes, continuous, endless. 1.272727, 0.236236. Just continuous, not endless. Like if you punch on your calculator 1 over 3, you can see it gives you that kind of decimal. 2 over 3, and so on and so forth. But terminating decimals are those that are non-recurring, or decimals which end. They have an end, like if you say 0.5 or 1 over 2, if you punch on your calculator. Or say if somebody says 4 divided by 5, you can also get 0.8 and so on and so forth. So those are terminating decimals. These are examples that have been given. How do we change from the recurring decimal to a fraction? So we can let our fraction, we can let our decimal be equal to x. So x is equal to 0.363. And then you can see there's one number being repeated, and it will be to 1 decimal place. So that's a 10. So multiply both sides by 10 to remove that decimal, and you get 10x is equal to 3.33. So that is the second decimal, and the first decimal we can label it as equation 1, and the second as equation 2. So which means you say equation 2 subtract equation 1. So our equation 1 is x is equal to 0.33 recurring, and 10x is equal to 3.33 recurring. So we can subtract, then you get here 9x, and then you get 3. Which means you have 9x is equal to 3, divide both sides by 9, and you get 3 over 9, which when you reduce x is equal to 3 over 9, you just get a third. So a third represents 0.33. That's how you change from decimal to fraction. You can do it also with the rest if they are repeating 2, the same thing. Approximations or rounding off. When they tell us we are rounding off, that means we are cutting off some values. or you're writing as an estimate. Like if they tell you to round off 3.8 to a whole number, which means you're going to cut off 8 and get a whole number. To do this, you look at the numbers you're cutting off. If it is 5 and more, then you cut it off and it carries the 1 to the number before 8. But if it's less than 5, it doesn't carry the number. Will not be correct. You not add a 1 to the previous activity. So that happens because we know that always the 0.5, or if you get 5, I'm giving an example like 0.5, is halfway. So which means anything halfway and more can really approximate your whole value. Yet anything below 0.5 is less than halfway, so you can't approximate the whole value. Like somebody gives you, if you had a mark like 38.5, somebody can say, no, we can give that person 39. If you had 49.8, somebody can say 50. But if you have 49.3, we don't approximate to 50, because less than halfway. So an example, you write a rough estimate of 3.8 and 4.1. You can decide to say 3.8 is the same as 4 and 4.1 is the same as 4. So the rough estimate is 4 times 4, which is 16. And the actual value is 3.8 times 4.1, which is 15.5. So this helps us to estimate our calculations and get an estimated value. So round off the following to the nearest whole number. 2 decimal places, 3 decimal places, 1 decimal place. They're giving these examples to try. Okay, so let us have a small break, then we can come off. You can try those. Then after the break, you can also look at some of the anticipated answers here. That you first try them without checking the answers, and how it can round off to 1 decimal place, which means you leave one way to a 10th. If they say 2 decimal places, you leave to 100th. 2 decimal places, if you're leaving 3 decimal places, you leave to thousands. You're cutting off up to when you have only 3 decimal places. So you try that and see if you can get those answers. So let us have a small break, then we can come up and close up the final part of this work by looking at basically how we can change from a fraction to a decimal. So let us have a small break then. Hello, be back. We need to continue from where we took a break. We had started on the idea of converting the fractions to decimals. So we want to pick it from there. We want to pick it from there. We were looking at a fraction which had 1/4 divided by 1 divided by 4. They're telling us to change a quarter to a decimal. So what we do here, you can use this division symbol. You say, put 4 outside and then 1 inside. 1 divided by 4 actually gives you, write a 0 here because you cannot just look at a quick whole number there. So which means you can put a 0 on the 1. So it becomes 10. Then 10 divided by 4 is 2. So you write a 2 up, multiply by 4, get 8. So now you can say 10 minus 8 is 2. You can put still a 0 so that you can divide. So 20 divided by 4 is 5. 5 times 4 is 20, which means you leave no remainder now when you subtract. So that means 1 over 4 is the same thing as 0.25. You can try another example. 2 divided by 3, convert to a decimal. And also use the same symbol there. Put 2, you can put 3 in front of the symbol, and then put the 2 inside. So when you do that, you can see 2 divided by 3, so you have put a 0, then put a 0 here, make it 20. So when you say 20 divided by 3, you get a 6, times 2 is 18. Then you can subtract 20 minus 18 to 0. So it keeps on. That means the value keeps on recurring. That's, you can call it a recurring decimal. So you can try a quiz here of trying to round off. We talked about approximations. How can you approximate 19796 to the nearest hundredth? When you talk about hundredth, that means to 2 decimal places. Then also write 4 whole numbers, 3 or 5 as a decimal. Then 0.016 as a fraction. Then convert 0.277 as a fraction. What is the rough estimate of 1009.3 times 1.998? Let's find the actual value. So if you start with the first question, you can first try it before you can give you the solutions here to that quiz. If you look at number 1, 1.19.796 is approximated to 1908. Why? 1980, sorry. The 100th, you're cutting off 6. So that means 2 decimal places. When you cut off 6, 1 is carried to a 9, making it 10. So you write 0 carry 1, then 1 carry to 7, making it 8. So when you cut off the 6, you're going to get 80 if you need to beat 2 decimal places or nearest 100th. Then question 2, 40 is already a whole number, so it's before the decimal point. Now you can only check 3 over 5, which is the same thing as 0.6. You can write it as a fraction as you've been doing. So which means you have 40.6, because when you add 40 plus 0.6, you're going to get 40.6. Then question 3, 0.016 as a fraction. You can see 16 is up to 3 decimal places. It will be 1,000. So 16 out of 1,000, when you reduce it, it goes to 16 divided by 4 is 4, and then 1,000 divided by 4 is 250. So you can say 4 out of 250. Then when they tell us to convert 0.2727 recurring to a fraction, that means we say let y equal to 0.277. So that one, you can put 3 dots to means repeating, and then it is endless. And then you can call that on equation 1. So since 27 that's being repeated is 2 decimal places, then that will be hundredths. So if it is hundredth, multiply by 100 to remove the decimal. So multiply both sides, y by 100, and then 0.2727 by 100. So you have 100y is equal to 7.2727 dash dash dash. That is equation 2. Now subtract equation 1 from equation 2. That means 100y, you subtract y, and 27.2727 subtract 0.2727. And you get 99, y is equal to 27. Dividing both sides by 99 gives you y is equal to 27 over 99. So when you reduce by 9, 3, and then 99 by 11. So the answer is 3 out of 11. Then the rough estimate of 1009 point, it was 1009.3 times 1.998. So if you're writing a rough estimate, you're going to cut off the 3 to make it a whole number, 1009 And this one, my rough estimate, the whole number is 2. Because when you cut off the 9, the whole thing goes to 2. So 1009 times 2 is going to be 2018. So the accurate answer there is if you multiply it as it is and you get 2016.5814. Okay, that is it. So if we are to move on and look at percentages, a percentage, what do we call a percentage? A percentage is a fraction of 100. A fraction where the denominator must be 100. The symbol we use for percentage is this. Of members have been looking at that symbol always, and you can write it after the value. Example, if let us express as a percentage, then we multiply the fraction by 100. Example, write 3/4 in percentage, which means 3/4 times 100. And that means 3/4 you already saw. Either you can take it to decimals and multiply by 100, or you can multiply as it is by dividing 100 by 4. That is cancel out and you get, or you can say 300/4 as we've been looking. There are many methods now. But if you say 3/4 in decimals, it is 0.75 times 100, you get 75. Okay, so you can try a quiz here. And the quiz is, number 1, convert 0.032 to percent. Then 2, of the 60 patients treated with a certain medication, 24 showed no improvement. What percentage of patients improved? Number 3, it has been reported that the revenue of a particular tablet in 2015 was approximately $54 million. That same tablet produced only $46 million in sales in 2016. What is the percentage decrease in sales for the tablet from 2016 to 2015 to 2016? Then finally, 20% of residents of a certain area expected to become ill this year. If 25,000 people live in this area, how many are expected to become ill? So you can try it before you can look at the solutions here to that quiz. So the answers to the quiz are 0.0032, the same as 32/1000. So in percentage, just multiply that by 100 and you get 3.2. In question 2, 24/60 times 100 gives 40%. Now, those are the ones that do not improve. So which means those improved we subtract from 100, since it's percentage. 100 minus 40 is 60. So 60 improved. Then number 3, the reduction should be $54 million, subtract $46 million, which gives you 8. So if you look at the percentage of that decrease, it will be the 8 divided by the original, which is 54. 8 divided by 54 times 100 gives you 14.8%. And then finally, 20% means 20 out of 100 times 25,000 gives you 5,000. So you can try them. Ratios. A ratio is a way of comparison between 2 or more quantities. In other words, it's a fraction. When they say 2 to 5, you can put a colon in between 2 and 5. But you can also write it as 2/5. Example in percentage. 25% means 25 to 100, or you can say 25/100. Increasing or decreasing ratios, you can say example 1, increase 300 kilograms in a ratio of 2 to 3. Why do you use that? If you say you're increasing, that means we shall change the ratio 2 to 3, change it to 3 to 2. And the new value will be 3/2 multiplied by 300. Get 3/2 times 300, which is 450. So when you increase, it becomes 450. You can have an alternative method by just actually multiplying that and then you add on, but we have simplified it using that idea of increasing the ratios. Example, to decrease $1 million by 10%. If you are
decreasing, you can cite either by first subtracting and say 100 minus 10, you get 90% of 1 million, which gives you $900,000. Or somebody can say 10% of the 1 million, which is 10 out of 100 times a million, and you get 100,000, then subtract from a million to give you $900,000. So you can try to use any of those methods. So you can try sharing as another example. Share 100 apples among Peter, Annette, and Moses in a ratio of 2 to 3 to 5. How many does each get? Solution, first get a total ratio. 2 plus 3 plus 5 is 10. So Peter will get 2 out of 10 times 100 because Peter is represented by 2. So 2 out of 10 times 100 gives you 20 apples. Annette, 3 out of 10 times 100 gives you 30%. That means 30 apples. Moses gets 5 out of 10 times 100, which is 50. So you can try a quiz. So now quiz, we have the first question. A batch of bread at the bakery is baked 18 minutes. How many batches of bread will this baker bake in 6 hours? Number 2, if Jake can ride his bike to a town that is 21 miles away in 45 minutes, how far can he ride in 1 hour? Number 3, decrease $2,000 by 5%. Number 4, James, John, Jonah, and Jackson shared money in a ratio of 1 to 3 to 2 to 4. If Jackson got $4,000, find out how much money was shared. Number 5, if the ratio of fuel a car and a motorcycle consume are given in ratio of 5 to 1. The car uses 75 liters. Find out how much fuel is consumed in a motorcycle. So you can pause, try that question before I can take you to the solution to that quiz. So you can say one batch is 18 minutes. What about X batches? That give you 6 hours. So you can convert hours to minutes, which is 6 times 60, because 1 minute is 60 minutes. So 6 times 60 is 360 minutes. And when you do that, you can say the ratio of 1 to X and 18 to 360. Either you can equate the fraction and say 1 out of X is equal to 18 over 60, 18 out of 360, then cross multiply and get your answer as 20. Or you can use our idea of increasing ratios, because you're increasing hours, that means also the batches must increase. So instead of writing 18 to 360, you write 360 out of 18 times 1, which gives you 20. As we conclude, you can also look at number 2. The solution is 45 minutes require 21 miles. What about 1 hour? It's X. So that means you can change hours to minutes, and then you have 1 hour is 60 minutes. So 45 to 60, and then 21 to X. You can write them as fractions. 45 out of 60 is equal to 21 out of X. Then cross multiply and get X equal to 21 miles. Or you can use your idea of increasing the ratios, as we have said. Because you have increased from 45 minutes to 1 hour, you can just use a bigger fraction or a bigger ratio. To decrease $2,000 by 5%, that means 2,000 you can multiply by 5 out of 100, and then you get 100. Then subtract 2,000 minus 100, get 1,900 or $1,900. Or you can use the other method that we talked about of first saying 100 minus 5, get 95% of 2,000, which is still the same answer as $1,900. Then number 4, the total ratio is 1 plus 3 plus 2 plus 4, which is 10. Percentage Jackson is represented by 2, so that means 2 out of 10 of X is 4,000. What is the value of X that gives you $20,000? So that's the amount that will be shared. Then finally, 5 to 1, and then 75 to x. Of 5 out of 1 is got 75 out of x, because multiplying gives you x is got 15 liters. So 15 liters will be shared. So that is the end of our discussion. And you can really, we shall meet in another module where we shall look at module 2 is we have algebra. Module 3 we have data or statistics, and then module 4 talk about business math. Module 5 matrices. Module 6 geometry. Module 7 similarity, and the scale factors. So thank you very much for really attending this discussion. We shall have more and more as we meet. Thank you. Bye-bye. We can always subscribe to my channel on YouTube, which I'll share later on as we move on with our discussions. So thank you very much. This. Kyebakoze Uganda Cranes badde bagitta nayo omugolo 3 ojja okukwata bungi temukebanga mmezi n'abantu mukole ate tulina okuba yakamenya z'abantu bongere eyokusatu kati balina kukomeka